Hello everyone. Today I am going to discuss about the Mathematics 2 first unit, Unit 1, First Order Ordinary Differential Equations. In this unit, total topics are first introduction about the differential equations. First topic is exact differential equations. Next linear and Bernoulli's equations. Next applications of first order differential equations, ordinary differential equations. In this application part we have two topics, that is Newton's law of cooling. Next one is natural growth and decay. Last topic from this unit is equations not of first degree. Not of first degree means we have three topics from this. Equations solvable for y, equations solvable for x, and Claret's equation. So in this one we have one more topic, that is equations solvable for p. So first introduction about differential equations. Definition of differential equation is: a differential equation is an equation which contains one or more terms which involve the dependent variable, independent variable, and derivatives of one variable with respect to the other variable. So derivative write by using dependent variable and independent variable. So equation of the form is dy by dx is equal to f of x plus f of y. So then we can write here x is the independent variable and y is the dependent variable, because of we write dy by dx. So y is depending on x, so that's why dy by dx equal to f of x plus f of y. F of x is a function in only x, f of y is a function in only y. So this type of equations are called differential equations. For example, dy by dx is equal to 5x plus 3 is a differential equation. Here x is an independent variable and y is a dependent variable. So dy by dx is a derivative of y with respect to x. So other type of equations also there in the differential equations, that is an equation involving a dependent variable and its derivatives with respect to one or more independent variables is called a differential equation. Means that in this type of equations we have only dependent variable and their derivatives, like y double dash plus 2y equal to 0, means d square y by dx square plus 2y equal to 0. So here y is a dependent variable, x is an independent variable, but equation have only y terms. So here in the second example, y double dash minus 2y dash plus y equal to 23. So this is also one of the differential equation form, but equation involving with only dependent variables and their derivatives with respect to independent variables. So this is also one of the form of the differential equation. So next, types of differential equations. So here we discuss with two types. One is ordinary differential equations, second one is partial differential equations. So here ordinary differential equations means an ordinary differential equation involves function and its derivatives. It contains only one independent variable and one or more of its derivatives with respect to the variable. So means ordinary differential equations involving with function and its derivatives, means that here function means f of x comma y, y dash, y double dash, so on, nth order derivative of y, so equal to 0. This is the ordinary differential equation form, like x plus y plus d square y by dx square is equal to 0, or d square y by dx square plus 2x plus y is equal to 0. This type of equations are called ordinary differential equations. Next one, partial differential equations. Partial differential equation that contains two or more independent variables. So here dependent variable is single but independent variables are two or more, this type of equations are partial differential equations. So that is dou square y by dou x square is equal to 1 by c square dou square y by dou t square. Here partial differentiation is defined or write as dou square, used by dou, not d, dou, because of there is a lot of difference between ordinary differentiation and partial differentiation. So in the partial differentiation we have to consider only whatever the independent variable is exist, so that is a variable, remaining all the variables are considered as constant. So that's why we can define with dou, that is dou square y by dou x square is equal to 1 by c square dou square y by dou t square. So this type of equations are called partial differential equations. So next one is order and degree of a differential equation. How to find the order and degree of a differential equation? Very simple one. So highest derivative exists in the differential equation, that derivative power is called the order of the differential equation. So that is here definition. A differential equation is said to be of order n if the nth derivative is the highest derivative in that equation. So that is called as order of the differential equation. So here highest power is n to the derivative, means d square y by dx square, d square y, d cube y by dx cube. So which highest derivative is exist in our differential equation, that derivative is called the order of the differential equation. So next going to the degree of the differential equation. So simply we can say that the degree of the differential equation means highest derivative power is called degree of the differential equation, but we have a condition that degree differential equation right in the polynomial of y power n, means polynomial of derivative of y, nth order derivative of y. So then only you have to take the degree of the differential equation. That is, the definition is, if the given differential equation is a polynomial n, here y power n means nth order derivative of y, then the highest degree of y power n is defined as the degree of the differential equation. So you need to write the differential equation in the polynomial. So what is the polynomial form of y power n? Is a naught y power n plus a1 y power n minus 1 plus a2 y power n minus 2 plus so on an. Here a naught, a1, a2 are so on constants. y1 y2 means y dash, y double dash, y triple dash are derivatives of y. So you need to write in the polynomial. After that you can take the highest derivative power, that is the degree of the differential equation. So here example is there, degree of d square y by dx square whole cube plus dy by dx minus y equal to 0 is 3. So how to consider the degree is 3? Here highest derivative is d square y by dx square, that power is 3. So next example is degree of d square y by dx square is equal to 1 plus dy by dx whole square whole to the power of 3 by 2 is 2. How to get this 2? First you need to write the equation in polynomial form. Means polynomial form means power must be integer, not in fraction. So that's why both sides you can take square, squaring on both sides. Here d square y by dx square whole square equal to 1 plus x dy by dx whole square whole to the power of 3, because of here whole square and 2 cancel, we get whole cube. Whatever the cube is there, but highest derivative is d square y by dx square. So that's why that power we get by squaring on both sides is 2. So that's why degree of the differential equation is 2. Next, solution of differential equation. How to write the solution to the given differential equation is a relation between dependent and independent variables and not involving their derivatives. In the solution there is no derivatives, only you have to write the relation between dependent and independent variables by solving different methods and apply the differentiation. Then we can get the solution, and relation between the dependent and independent variables which satisfies the given differential equation is called a solution or integral of the differential equation. So means that if you solve a differential equation, you can get by using integration also, but we have number of methods to solve a differential equation, so that's why we use that differential equation methods. So then we get a relation between dependent and independent variables, that is called the solution of a differential equation. So first topic in the first unit is exact differential equation. So how to write the form of the exact differential equation is, if the equation in the form of mdx plus ndy equal to 0, that equations are called exact differential equations by using the condition of exactness, that is dou m by dou y equal to dou n by dou x. So but how to write mdx plus ndy? Before going to that, you have to consider a function f of x comma y, then df, derivative of that function is right as dou f by dou x into dx plus dou f by dou y into dy. Here m is dou f by dou x, n is dou f by dou y. So then we can use that equations, then we can find the equation to the mdx plus ndy form. So let mdx plus ndy equal to 0 be the first order and first degree differential equation, where m and n are real valued functions for x comma y. Then the equation mdx plus ndy equal to 0 is said to be an exact differential equation if there exists a function such that dou f by dou x is equal to m and dou f by dou y equal to n. So here we have a differential equation constructed by using dou f by dou x and dou f by dou y from f of x comma y, that is the form is mdx plus ndy equal to 0. This type of equations are called exact differential equations, but that should be satisfy the condition dou m by dou y equal to dou n by dou x. So here we can write the differential equation in the form of mdx plus ndy equal to 0, and you need to check the condition dou m by dou y equal to dou n by dou x, then that type of equations are called exact differential equations. Here example is 2y sin x plus cos y into dx minus x sin y plus 2 cos x plus tan y into dy equal to 0. So first you need to check, is this equation in the mdx plus ndy form or not? If it is in mdx plus ndy form, then you need to check the condition for exactness, that is dou m by dou y equal to dou n by dou x. If the exactness condition satisfied, then you can go to the general solution of the exact differential equation. So that is working rule to solve an exact differential equation. Step 1, check the condition for exactness. First you have to check, means first you have to write the m value and n value. Find dou m by dou y and dou n by dou x. You can find dou m by dou y equal to dou n by dou x. If this equation satisfied, then go to second step to the general solution, that is integral mdx plus integral ndy equal to c with conditions. What are the conditions? Integral mdx we consider y constant, plus integral ndy only those terms which do not contain x, means simply we can call it as independent of x terms like y square, 1 by y cube are constant terms. Without x terms we have to consider for n and integrate with respect to y, that is equal to c. This is the general solution for exact differential equations. So Next, how to find the integrating factor for non-exact differential equations. So if the equation is non-exact, how to get the non-exact differential equation? If the equation mdx plus ndy equal to 0 be non-exact or not an exact differential equation, dou m by dou y is not equal to dou n by dou x, then mdx plus ndy equal to 0 can be made exact by multiplying it with a suitable function called an integrating factor. So this equation is non-exact. We have 5 methods to solve a non-exact differential equation by multiplying with suitable function that is called as an integrating factor. So here example is there, y dx minus x dy equal to 0 is not an exact differential equation. So how to get it is a not exact? Here m is equal to y, n is equal to minus x. Dou m by dou y value is 1, dou n by dou x value is minus 1. So both are not equal to. Then how to find the integrating factor to this equation? Because of dou m by dou y not equal to dou n by dou x here. So first we have to check the general solution to the exact differential equation. After that we can go to the non-exact differential equations, means equations made as exact. So that is first exact differential equation. Solve the differential equation 2x minus y plus 1 into dx plus 2y minus x minus 1 into dy equal to 0. First you need to check the differential equation is in the form of mdx plus ndy. So that is given differential equation, you can write it. Take m is equal to 2x minus y plus 1, n is equal to 2x minus 2y minus x minus 1. So dou m by dou y, differentiation with respect to y. So already we discussed, if you apply the partial differentiation, then here with respect to y means only y is variable, remaining all the variables are considered as constants. So that's why 2x derivative is 0 minus y derivative is 1 plus 1 derivative 0. So that's why we get here minus 1. And n is equal to 2y minus x minus 1. But we need to find dou n by dou x, that is equal to minus 1. How to get this minus 1? 2y derivative is 0 minus x derivative is 1. So that is dou m by dou y equal to dou n by dou x. Because of dou m by dou y value minus 1, dou n by dou x value is also minus 1. So that's why dou m by dou y equal to dou n by dou x. So the given differential equation is exact because of it satisfies the condition of exactness, that is dou m by dou y equal to dou n by dou x. So next you have to write the general solution for the exact differential equation is integral m dx, here y constant, plus integral n dy, only those terms which do not contain x, equal to c. You need to write the general solution completely. After that you can substitute the m. M value is 2x minus y plus 1 into dx, here y constant, and only those terms which do not contain x, need to check the n, which term is not having x, you can take that 2y minus 1. X, don't consider the x because of here x term is there, so that's why no need to take it. You can take 2y minus 1 for n, 2y minus 1 into dy equal to c. So in the first integration part, y is constant, don't touch the y terms, just y keep outside, right outside, and integrate the terms, whatever the integrand terms are there. Here 2 is a constant, x is a x dx, integral x dx is x square by 2 by using the formula integral x power n dx is equal to x power n plus 1 by n plus 1. Here n value is 1. So that's why we get x square by 2 minus y is constant, integrand is 1, integral dx is x plus again integral dx is x. So that's why 2 into x square by 2 minus xy plus x. So that is the first integral part plus here 2y is there, we can find the integration with respect to y. So that's why 2 into y integration is y square by 2 minus integral dy is y. So that is equal to c. Next you have to write it 2 cancel x square plus here also 2 cancel y square minus xy plus x minus y equal to c. This is a required general solution for the given differential equation. Next example is y square minus 2xy into dx equal to x square minus 2xy into dy. Solve the differential equation. Here it is not in the form of mdx plus ndy, but we have a possibility to write in the form of mdx plus ndy. If you take this term into LHS part, we get the equation in the form of mdx plus ndy equal to 0. That is the given differential equation, right, as y square minus 2xy dx minus x square minus 2xy dy equal to 0. So here dx coefficient is considered as m and dy coefficient is considered as n. So that's why I write m is equal to y square minus 2xy. N is equal to, we can multiply with minus also because of we are comparing with mdx plus ndy plus. So that's why n is equal to minus of x square minus 2xy. So that's why here multiply with minus x square plus 2xy. After that you need to check dou m by dou y equal to. So here y square derivative is 2y minus 2xy derivative is 2x because of 2x is constant. Here y derivative is 1. So that's why 2y minus 2x. Next n is equal to minus x square plus 2xy. So that is dou n by dou x equal to x square derivative is 2x minus 2x plus 2xy. That is here 2xy derivative is 2y because of 2y is constant, x derivative is 1. So that is 2y. We get 2y minus 2x. So both the terms are same. So that's why dou m by dou y equal to dou n by dou x. So the given differential equation is exact differential equation. Therefore the general solution is integral m dx y constant plus integral n dy only the terms independent of x equal to c. So then we can take y as usual, y square minus 2xy into dx. Whatever the m is there you can substitute it, but at the time of integration you can consider y is constant plus integral n dy. Any term independent of x from n? No, because of all the terms are with x. So that's why there is no term independent of x. So that's why we can write here 0 into dy equal to c. So we can integrate with respect to x. Y square is constant right outside. Integral dx is x minus 2y is constant right outside. Integral x dx is x square by 2. So 2 get cancel here. We get the solution is xy square minus x square y is equal to c. And next one is inspection method. Already we discussed if the equation is non-exact. So when it is non-exact, if dou m by dou y is not equal to dou n by dou x, so then equation is not an exact differential equation. We have to make the equation as exact by using the multiplying with integrating factor. So in that one, 5 methods to find the integrating factor to the given first order differential equation. So first method is inspection method. So that inspection method is by using the sum derivatives, means differentials. So that sum of differentials are there here. We will discuss that. That is first one is d of xy equal to x dy plus y dx. Here we are using the formula u v dash plus v u dash. So next d of x by y, y dx minus x dy by y square. Here we are using the formula u by v. V u dash minus u v dash by v square. Next, d of derivative of y by x is equal to x dy minus y dx by x square. Here also same u by v formula. Next, d of x square plus y square by 2. So derivative of x square plus y square is 2x dx plus 2y dy. But 2 is there by, so that's why 2 common, 2 to cancel, x dx plus y dy. If you remember these formulas, or if you get an idea about this derivatives, then directly you can find the integrating factor to the given differential equation and you can make it as exact differential equations. So next formula is d of log of y by x equal to x dy minus y dx by xy. How to get this one? Differentiation of log x is 1 by x. In the place of x we have y by x, so that is you can write log x differentiation is 1 by x. After that you can differentiate y by x. So log means whole function differentiation, you need to write it, and base function is here y by x. Y by x differentiation you can write it, and cancel the terms, we get the form is x dy minus y dx by xy. Next equation is d of log of x by y. Same rule you can apply it. We get y dx minus x dy by xy. And next one is d of tan inverse of x by y. If you know the derivative for tan inverse x, simply you can apply in the place of x by y. So here tan inverse x derivative is 1 by 1 plus x square. So you need to take x equal to x by y, and you need to write the x by y derivative separately and multiply it. We get the form is y dx minus x dy by x square plus y square. Next, d of tan inverse of y by x, that is equal to x dy minus y dx by x square plus y square. So next one is d of log of xy equal to y dx plus x dy by xy. Next is d of log of x square plus y square. First you have to write the log function derivative 1 by x square plus y square into x square plus y square derivative is 2x dx plus 2y dy. 2 right outside, we get this form. Next, last one is d of e power x by y. U by v we are applying it, y e power x dx minus e power x dy by y square. If you remember these derivatives, or if you get an idea about these derivatives, directly we can get the solution to the given differential equation if it is non-exact. So here solve example is solve x dx plus y dy is equal to x dy minus y dx by x square plus y square. So if you see this one, directly we can get an idea about the d of x square plus y square by 2 because of x dx plus y dy. We get for this x dx and y dy is derivative of x square plus y square by 2 equal to x dy minus y dx by x square plus y square. Here we get an idea about the tan inverse function with y by x. So that is d of tan inverse of y by x. So this is taking from the equations of whatever the differentials are there. So from that we write d of tan inverse of y by x. If you integrate on both sides, differentiation cancel, then we can get x square plus y square by 2 equal to tan inverse of y by x plus C, which is the required general solution. Next example is y dx minus x dy by x square plus e power y dy equal to 0. Here the term with the denominator is x square. Denominator is x square means you need to write the y by x form. So that's why here first you need to write x dy term. So that's why common minus x dy minus y dx by x square plus dy e power y into dy equal to 0. After that you can write. So here there is no other formulas for e power y. So directly you can integrate it. Then we can get the solution for e power y. So that's why don't touch that e power y. E power y into dy is equal to this term taken to this side, that is from LHS to RHS you can take it, then sign will change, that is x dy minus y dx by x square. So we have a formula for this from differentials, that is d of y by x. So integrate on both sides, integral e power y dy equal to integral d of y by x plus c, because of we are integrating. So you can add the c term. So then here integration of e power y is e power y plus derivative integration cancel, the value is y by x plus c. This is about the inspection method. In remaining 4 methods we will discuss in the next class.